Okay, test-inspired warm-ups. Lots of stuff going on with number one, and it looked like most of you had most of the pieces, but did you get all the pieces in all the right places? Derivative of log is 1 over the argument, so 1 over sine of x squared. And then the derivative in the top, so cosine of x squared. And if you stop there, I would say you're like halfway right. I mean, none of that's wrong, you're just not done yet, because we need to chain rule. What's the derivative of x squared? 2x. And then the fact that this is a base 7, most of you caught that. Natural log 7, but where does that go? In the top or in the bottom? In the bottom. So, I mean, that's a perfectly fine safe stop right there. So yeah, free response, you'd leave it. If you wanted to clean it up, you could get real fancy and say cosine over sine is cotangent. That would be a fancy way to go, but unnecessary. So the main thing was derivative of log is 1 over the argument times the derivative of the argument, but don't forget the chain rule. And then also that base was 7, so you had to account for that. Number 2, limits. What's our first attempt on any limit problem? Even before then, plug it in. Now, pretty quickly this turns into 0 over 0, so that's not going to work. Then let's try factoring. So I can take out a 3 and an x squared from the top. So x to the 5th plus 2. And then in the bottom I can take out a x squared. That leaves 5x to the 4th plus 2. And then I can cancel the x squareds. That's good. That might fix the 0 over 0 thing. And then try again on the substitution. So I've got 3 times 0 plus 2 over 0 plus 2. And I guess as a safe stop you could leave that, but that's also known as 3. So the main thing on there was recognizing, try substitution, but then do factoring. Not what some of you wanted to do was the top no, bottom O equal co stuff. When are you allowed to use top no, bottom O equal co? That's when x is going to infinity. So it's a great shortcut, but only for x going to infinity. And that was not that problem. So be careful. You get suckered into remembering the little catchy phrase and using it when you're not supposed to use it. Number 3, like you guys said, you're going to set these two things equal to each other. It's piecewise, so you're sort of checking to see if when it gets to 1, you know, do they match up, or is there a jump? And I guess it's not really a question. It's like make it continuous, make them match up. So we want k e to the x minus 1 to equal 2kx minus 4, but all of that to happen at x equals 1. So I need to plug in x equals 1. E to the 0, that's nice. 2k minus 4, this is e to 0 is 1. So yeah, the algebra on this is pretty easy once you get it set up. K equals 4. So easy problem, but the concept is if you want them to be continuous, they need to match up at x equals 1. So you set the two equal to each other and see what, or force it so that they match. All right, again, 3 test-inspired problems there.